All right, so when we're naming acids, first of all, how will we recognize if something's an acid? If it is the name, it's going to say something acid. That's how you recognize that. But if it's a formula, it's going to begin with an H, with the exception of water. Okay, so anytime you see a formula written and it begins with an H, it's probably going to be an acid again, unless it's water. Okay, so there are basically two types of acids that we're going to talk about. The first type is called a binary acid, and it basically is hydrogen and one other element with it. It contains no oxygen, okay? So when you see an acid and there's not any oxygen present, you're going to use the prefix hydro. So you're going to add hydro in front of it, and then whatever element's with it, you're going to change its ending to ic, okay? So for this example, HCl would be hydrochloric acid. Okay, all of your binary acids end in ic, all of them. Okay, all binary acids end in ic. If you have oxygen present, we call those oxyacids. For oxygen acid, okay, they are going to be hydrogen with one of your polyatomic ions. Okay, and what are polyatomic ions? Give me some examples. Give me some examples from your pink sheet. Well, that won't be an acid because it's got acetate, sulfate, bicarbonate. Those are all examples. Actually, it is. It is. It's just not on there. Yeah. Fluoride is not on there.
Yeah, it is. It's the last one. It's the last one.
Huh?
It's a last one.
Oh, are you saying borate?
Yeah.
Oh, I thought you were saying fluoride, like fluoride. And I'm like, it's not on there, but you're going to have to use it. So, my confusion up here. Old ears here. Okay. All right. So when you have an oxyacid, if you have one of the polyatomics and it ends in the 8 sound, you're going to change it to ic. Okay. If you have the polyatomic and it ends in ite, you change it to us. Wouldn't be a bad idea to write that down on the bottom of your pink sheet. 8 to ic, ite to us. Okay? When we were learning the polyatomics, I told you you could always know which one had the higher amount of oxygen because it ate more oxygen, right? And the lower one was ite because it was like, I don't need any more. Okay? So the way you can remember this is the one that ate more oxygen feels icky, so it's 8 to ic. Okay? 8 to ic. And then for the us, it's jealous because it has less oxygen. It's just some ways to help you remember it. If you don't like my ways, you can come up with your own ways, or you can just ignore what I just said. But sometimes that helps you on a test, okay, or a quiz. Okay? So let's get to it. Let's practice. This is not in your notes. I'm just showing you some common root words of what they come from. The only one you got to be a little careful on is the sulfite, and phosphite. You do not change it to like sulfic, it's sulfuric. So those two, you got to put the R sounds back in there. So phosphorus goes to phosphate, but it would be phosphoric, okay, or phosphorus. I don't know why, just I think they did it just to confuse high school chemistry kids. All right, HNO2. What is NO2? Nitrite. So ite goes to us. There's oxygen present, so we do not use hydro. So this would be nitrous acid. Okay? We already did HCl. There's not any oxygen present, so we have to use hydro. Hydrochloric acid. And yes, before someone asks, you have to write the word acid on the end. Okay? How about H2SO4? SO4 is what polyatomic? Sulfate. And 8 goes to? Nope. 8 goes to ic. So this would be sulfuric acid. Hydrochloric acid? No oxygen. Hydrogen. You put the prefix hydro when there's not any oxygen present. Okay. Actually, for the rest of these, it's gonna have hydro on there because there's no oxygen. Okay. So what would HBr mean? Hydrobromic. Okay. So it would be hydrobromic. How about H2S? Hydrosulfuric. And this is where I want to show you it's very important whether you put that hydro when you need it and when you don't, because there's a big difference between this acid and this acid. One is sulfuric, one is hydrosulfuric. Hydrosulfuric acid is not very common. Sulfuric acid is an extremely strong acid, such that when I dilute it, I have to put it in a water bath because it generates so much heat. It's a very strong acid.
I have a quick story about H2S.
H2S, this one? Hydrosulfuric?
My dad he was at a man camp for CDM.
A man camp?
Yeah, it's like where all the operators go.
Okay.
For a chemical plant or an oil refinery or something.
Okay.
And he was testing H2S on something, and he spilled it on the table, but he was wearing rubber gloves because it'll eat up your skin and like one drop will kill you or something. And he was cleaning it with paper towels, and it just started burning.
Yeah.
And it burnt holes in the...
Yeah, especially the strong acids, and if they're really concentrated, are very dangerous. Yeah. That's why it's important to have the right formula. Yeah. Okay. So that's how we name them. So now let's talk about how we put them together. If we make the formulas. Okay. Hydrogen, I already told you, is always going to come first. Right? Hydrogen's a +1, so you're just going to balance the charges just like when we're putting ionic compounds together. So this is an example of phosphoric acid. Phosphate is a -3, so it takes 3 hydrogen to go with it because it's a +1. So we get H3PO4. Okay? So if y'all did pretty well on the ionic formulas, you should be able to do the acid formulas. Good. Well, not good. Well, so I don't teach you English. Hi.
For like this one, because on these example ones down here, for like the one that's HI, which would be, I'm assuming it would be hydro, and then would it be iodide or iodic?
Iodic. You remember you changed the ending for all the binary acids, they all changed their ending to ic.
So the ones that end in like I, you change it to ic.
Uh-huh.
Same with like chloride.
Uh-huh. Like fluoride would be hydrofluoric acid.
Okay.
Okay? Yeah, all of the binary acids get changed to ic. On the oxy, your ates get changed to ic, and your ites get changed to s. So most of your acids are going to end in the ic sound, IC. So let's do a couple of these. Nitric acid. Nitric, ic came from 8. So it's coming from NO3, which is a -1 charge. So how many hydrogen would I need to put with it? Just one. So it would be HNO3 would be its formula. Okay. Acetic acid would be acetate, which is C2H3O2, -1 charge. So how many? 1. Sometimes you will see acetic acid written like this on some worksheets. It's the organic chemist way, so you need to be able to recognize it. It's literally the structure or what it looks like. It's called a structural formula. So if I were to draw out that structural formula in the Lewis diagram, it would be a carbon attached to a carbon and then 2 oxygen. That's why it's drawn that way. How about carbonic acid? Carbonic. Ic came from... So 2 minus. So how many hydrogen? 2. All right. How about chloric acid? Ic. No, it's not hydrochloric. It's chloric. So what I would come from chlorate. So what is chlorate? We're just going to make that its minus sign now. So how many hydrogen? ClO3. All right, chlorous acid came from chlorite. Chlorite is ClO2 minus, so also HClO2. And then lastly, we have phosphorus acid. Came from phosphite. If you don't see hydro, then go look for a polyatomic. Okay. And so that's a -3. Or 3 minus, whichever way. So it'd be H3PO3. Okay? Any questions on that? Okay. Find a little spot to write these because I'm going to give you a little tip here. And my tip is this. There are some acids that it really will just do you good to just memorize them because they're going to come up so often. And so I'm going to give you a list of ones that you should memorize. H2SO4 would be sulfuric acid. Now, am I going to test you on this memorization? No, but it will make your life easier. HNO3, nitric acid. H3PO4, phosphoric acid. HClO4, anybody want to guess what that one is? Perchloric acid. Because ClO4 is perchlorate, so it would just be perchloric acid. And then HCl, HBr, HF. Now we use hydro because there's no oxygen. So we would have hydrochloric acid, hydrobromic, and hydrofluoric. Now, when you take your quiz on Thursday, spelling counts, guys and gals. Got to spell it right.